Okay, so we're going to convert in lab from grams to moles to atoms. We're also going to do problems using that. When we do this, there are really 6 different types of conversions, but they break down into 2 types of problems. And one of the best things you can do early on is try to remember which types of problems are which. And that's like one of the first things you should ask yourself when you get these problems, because later on they become more involved. So we have 2 types of problems. The first one I'm going to call 2-step, and the second one I'm going to call 3-step. When I'm doing a 2-step conversion, that's going to be grams to moles or moles back to grams. That's one type. The second type is moles to atoms or atoms to moles. So technically there's 4 kinds of problems under the 2-step. So I convert grams to moles, or I can give you moles and ask you to convert it to grams. That's 2 different types. And I have 2 different types here. When I get to the 3rd step, or the 3-step problem, I'm doing grams to atoms, or atoms back to grams. Now, if you have trouble setting this kind of stuff up, if you can remember this GA3, grams to atoms, 3 steps, anything with grams and atoms in it, 3 steps, then you know every other kind of problem is 2 steps. It makes it easier. If you remember one, you should know the other. And the other thing I have to show you, because I don't know how much you use this kind of thing in math, I'm sure you've done things before called dimensional analysis, but I doubt if they actually called it that. So it's really kind of weird. You set up a system of boxes. You'll have, for you guys right now, you'll have boxes. This would be a 2-step. This would be a 3-step. And what that line tells me, because this is what people don't usually know, what the line tells me is if I'm above the line, I multiply. If I'm below, it's telling me to divide. So this part down here is a division. And I'll show you when we do like a real problem. So if I have 2 numbers side by side, I multiply them. If I have a number down here, I would divide by it. And we'll practice some so that you'll get the hang of it. Same thing over here, only I just have an extra set of boxes because it's a longer problem. If you do this right, these help you a lot in your setup. But you have to pay attention and get how you use them. So now let's just try something. Let's start with our grams to moles. These will be your problem types. This will be grams to moles. And then I want you to go back to that list we just made, and I want you to tell me, is that a 2-step or a 3-step problem? You in there? 2-step, good. So I'm going to make these pretty short and concise. Sometimes the ones in your homework won't be this short, but so we can get through them and you can have plenty of examples, they're not going to be real wordy. It'll be something like this. How many moles of calcium chloride, CaCl2, are present in 716.4 grams. Okay, so Xander already told me this is a two-step problem. So I'm going to draw my boxes. And I would say that rule one that we always follow is this. The given goes in the first box. So you go to your problem, you find your given, and you carry it down. 716.4 grams CaCl2. So we've got that in there. Then the second thing we need to do is evaluate and see what unit needs to cancel out. So when I look at this, what's the only unit I have? Grams. So that tells me grams CaCl2 has to be down there. I just have to figure out what number needs to go with it. Now I want you to think back over the last, I don't know, it's probably been 4 or 5 days. We've been working with one thing off the periodic table that we found the parts for, and we put them all together to get something. Do you know what that was called? We used it in percent composition. I gave you a list of chemical compounds, and we calculated it.
Grams per mole?
It is grams per mole, but what is that? Those are the units for what?
Mole.
Good, molar mass. So, when I have to find out how much of something there is, I always have to use molar mass. So my molar mass will go here. So let's take a minute and calculate my molar mass. I've got calcium, and you guys can do this, and chlorine. I've got 2 of those, and I've got 1 of these. So you guys figure out the molar mass for me. When you've got it, stand up. So when I want to cancel out grams, I have to put the molar mass in the box below. Find someone to check with. So maybe we have a little bit of disagreement, it sounds like. Anybody not agree?
Yeah, we don't agree with her.
Not agree with her, who's her? Mary?
Mary.
Well, let's look here. Calcium is 40.1 and chlorine is 35.5. So that is, and I have 2 of them.
Let's see.
40.1. Ooh! That's not right. I didn't put, it should be 111.1.
Yep.
Yes? Any questions about how I got that? Good? All right, I'm going to put it down. 111.1. So when I have to cancel grams, I know I have to use molar mass. Now, tell me this. That is the number of grams in what?
1 mole.
1 mole. 1 mole. Goes up top. So look, my grams cancel out, and I'm left with the unit I want. But before you calculate, write this down. The only number ever used for moles is 1, unless it's the given in a problem. And if it's the given in the problem, what box is it going to be in?
Top right.
Yeah, first box, top box. All right, so let's calculate this. 16.2 divided by 1. See what you get. Round to the 10th place. What'd you get, Evan? So I would write 6.4 mole CaCl2. And there's my answer. What's wrong, Mary?
Would that go in the last box?
No, that's just estimate. That's just the answer because I ran out of room.
Okay, so would that go in like the other box?
Like if you wanted to put more boxes? I don't
No,
know.
I
Yeah,
need
yeah.
716.2.
No, this is always just a 1. Now I finally know what you're saying.
Why is it one?
Because if we're setting up fractions for this to be 716.4, it needs to be over 1 mathematically. So really, I leave it empty. You don't have to write the 1 in there, but if it helps you keep it straight, write the 1 in there. Are we good? Let's try another one. See if you can look through it. Okay, I'm going to set this one up even simpler. Are you ready? Let's go 328 grams of aluminum oxide equals how many moles? Aluminum oxide. Now I'm going to let you try to set it up. 2-step, obviously. And then I'm going to try to let you go from there. Use the model we just did. And then we'll fill it in. Raise your hand if you're still working. Okay. Okay, Lindsay, what goes in the first box? Okay, you guys agree with her? So what units do I need to cancel out, Lucas? Grams. And you cancel out grams. So, What do I have to figure out to put in this box, Maria? I have to figure out the molar mass. So I should have had AL 2 times 27.0 and oxygen 3 times 16.0, which equals 102. So I'll put 102 right here. And that is the number of grams in what, Shelby? 1 mole. So 1 mole goes up top. And then all we have to do is plug it into our calculator. And Mary, what'd you get for an answer?
3.2.
3.2 mole aluminum oxide. Raise your hand if you got that. Okay. Any questions? Yes,
So
sir.
is this basically just like a proportion?
It is a proportion, and when we start doing experiments with chemicals, you'll use these to figure out what proportion of this should be with what proportion of this. Lucas?
What is that?
Like, the grams need to be gone, because I want to end in moles, so it's proper math.
Yeah.
It's getting rid of your units and getting to the unit you should be to. Xander? How do you what? We're going to do that next. That's going to be our next step. Let's flip flop it. Let's do moles, grams. And we'll just walk through one. Moles to grams, so 2-step or 3-step? 2-step, good. So, let's look at one. Let's say 3.7 mole of hydrochloric acid is equal to how many grams? And somebody already told me this is a 2-step list. And it doesn't change, the given still goes in the first box. So I go up here and I find my given. So that would be my 3.7 mole hydrochloric acid, and remember that's just like it's over 1. Now, what do I have to cancel out in this one? It's different. Moles. What's the only number I can use with moles unless it's given to me in the problem as the given? 1. So I'm going to put my 1 mole down here. What do I want to end in? Grams. So what do I need to do next? Find the molar mass. So I've got H and I've got Cl. 1H, 1Cl. This is 35.5 grams. This is 1 gram. So that is 36.5 grams per mole of hydrochloric acid. So these things cancel out just like they should, and it becomes a really simple multiplication problem, whatever that is. How about 135.1 moles mole grams HCl. See if you get that. Yeah, we're sure we match. Multiply. Above the line I multiply. Technically I'm supposed to divide by 1, but we know it doesn't make any difference. All right. Ooh, we're not even anywhere near the 3 steps. Let me give you one more of those to try. 7.48 mole sodium hydroxide equals blank grams sodium hydroxide. Totally figure it out. But we've done grams to moles, and now we're doing moles to grams. We still have 4 types of problems left. Set up look like mine? What's your friend answer? Carson, do you have an answer? 299 point what? Is that what you guys got?
Put 2.
Point 2? And that would be grams of any, I got point 2. I wonder, did you say one of these got farther, maybe? There you go. Okay. Any questions before I show you a different time? So what do we have left in our 2 steps? Can you look at your little list and tell me? Okay, we'll do that next. Moles to atoms. And the next 2 we're going to do, because next we'll do atoms to moles. These are the easiest ones, I think, because you don't really even have to use the periodic table. Moles to atoms, is that a 2-step?
Yep.
Yep. Okay, so let's say I have 4.9 mole, and I'm going to use the salt. NaCl contains how many atoms? NaCl. So you just told me it was a 2-step problem, and you're right. So what is my given, Jacob? Good. 4.9 moles NaCl. What do I need to cancel out? Moles. So what do I need down here? I need 1 mole. So I got rid of that. Where do I want to be in the end? Atoms. Woo! We haven't used this yet. How many atoms are in 1 mole of anything? What, Mary? Yay! 6.02. Don't tell me a lot. Times 10 to the 23rd. So look, I didn't even have to go to the periodic table for anything. I just had to remember that number. Whose number is that?
Good.
Now, how are we going to put this in our calculator? Let me help you. It's a multiplication problem, but
Look at first 2 to 6.
yes, yeah, parenthesis your second one. Anytime you're using these, you're going to parenthesis. I like to put it in like this, especially if you have a TI-84, because sometimes it screws up scientific notation. 4.9 and then hit enter times parentheses 6.02 times 10 to the 23rd, parentheses. And I got something.
Wait, times what? 6.02.
6.02 times 10 to the 23rd. So you put this in, hit enter, then multiply, put this in parentheses and hit enter again. And you should get this, really 3.0 when I round correctly, times 10 to the what? 24th. If you have one of these, follow it to the end. Do you see that little E and then a number? Some people don't know what that means, and that's okay. So if you're one of those people, that's telling you times 10 with the exponent 24. That's what that means. That gives you your exponent. So that's how I got that. And that would be what? Atoms, NaCl. Let's see if we can get through this one. I'm going to give you one of these to try, and then I'll show you the last type we're going to do today.
And then what goes in the box is right under the 4.0.
A 1. It's just over a 1. Sorry, I need to start writing that in. Okay, so let's try this one. 13.2 mole sulfuric acid equals how many atoms of sulfuric acid? So set it up. Do it. Stand up when you're done. Tired, Connor?
No.
Am I boring you, Connor? Look, he doesn't answer me. All right, find something to check with. Am I right?
Yes.
Good. All right, I'm going to show you the last one, and then I'll be done. Last one, still 2 steps. We're going to do atoms. Per mole. So let's do 9.8 times 10 to the 27th atoms of lithium chloride equals how many moles? So this is my last type of 2-step. So I'm going to bring my given down, 9.8 times 10 to the 27th atoms. And that's over 1. So there's my given. Yeah, what do I need to get rid of? I need to get rid of atoms. I should have written LIS here. What's the only number I can use for atoms if it's not given? Yeah, Avogadro's. So I've got to put that down here. And that's the number of atoms in what?
It's a mole.
Yeah, so 1 mole goes up top. Look at that. So this one becomes then a division problem essentially. Times 1 divided by 6.82 times 10 to the 23rd. So put in your 9.8 times 10 to the 27th and hit your enter key. And then divided by and put your 6.02 in parentheses. Well, I hit something wrong. Oh, it's not in scientific notation. Is yours?
No.
Did you get an answer?
Yeah.
So let me tell you this rule. If you're working with scientific notation anywhere in your problem, it needs to be in scientific notation. So this is what I got. So basically I can work with that, and that would be mole LIF, but if I want to put that in scientific notation, I just count back. 1, 2, 3, 4, and I'd say 1.6 times 10 to the 4th, because I want my number to get bigger, LIF. Yeah.
That's a lot of moles.
That is a lot of moles. That's a lot of parts, too. All right, one more to try, and I'll stop talking. I promise. Well, I don't really want to promise. Question? No? We're good? All right, let's do 3.45 times 10 to the 26th
No.
atoms water. What? 26, yeah, actually. Equals how many moles? H2O. Figure it out. And you have the answer. Figure that out. Put it in scientific notation too. What'd you get for an answer?
5.7 times 10 to the
5.7 times 10 to the second is correct. Be sure you get that. Have a lovely day.
second. You just visit this up.
We're going to start with that tomorrow. Work through some, and then we'll learn the 3-step rule.